Year 9. So I just want to start today by quickly going over your homeworks. I've commented on them all. In general, really well done. Really good answers. Just maybe a wee bit of detail lacking in some people's answers. Now, this one here, so whenever the northern hemisphere is tilted towards the sun, it's going to be our summer. And basically that's what I'm looking for in your explanation. So mine's not perfect. I tried to get as much in as I possibly could. So the northern hemisphere is tilted towards the sun, so that gives us longer days and shorter nights. And then the southern hemisphere is tilted away, so it's the opposite. It has shorter days and longer nights. For the day length and the temperature, obviously it's not the same as the temperature, so I've just given a range. You may be outside of that range, but that's still fine, as long as I suppose the pattern of the temperatures is right. The next one then I would fill in here would be the winter one, and it's the explanation is here if you want to pause and get that written in, but it's just basically the opposite of what I put for the summer one. So the northern hemisphere is tilted away from the sun, so it's our winter. Southern hemisphere is tilted towards the sun, so it's their summer. And then because we're going in this order, you can use the order of the seasons to figure out, well, I suppose you could use the date as well, but this one here is autumn and the days are half and half, and the season in Australia is spring. And then up here it's just the opposite situation. Okay, so if we look now at 139, the circular path that the Earth takes as it goes around the sun is its orbit. And then this one here, a couple of people misunderstood that. How do we know it's not drawn to scale? Because the Earth is like way smaller than the sun, and it's drawn here at nearly the same size. Also the distance is way off, but it wouldn't really be possible for us to draw it on a page and actually see the Earth on the page. So for that I was really looking for you to talk about the difference in the size of the sun and the Earth and the terrible distance that's shown here. Now see, this is probably where the most mistakes took place. So see, if I was answering this, I would start off with D, right? Because I think it's the easiest for me to figure out. So for D, the northern hemisphere is tilted towards the sun. So that means it's our summer because we're getting longer days and shorter nights. So D, summer for the northern hemisphere. And then we know the southern hemisphere is always just going to be the opposite, so it's going to be winter. Then I would probably do B next, right? So if I go to B and I look at it, the northern hemisphere is tilted away from the sun. So that means we're going to get shorter days and longer nights. So for B, northern hemisphere, that's our winter. And then the southern hemisphere, the southern hemisphere is the opposite, so it's their summer. Now, the most common mistake was people mixing up spring and autumn. So here's how I would do that. I would say write D, and I would always think for us for the northern hemisphere, so summer and then some sort of season and then winter. Well, what comes in between summer and winter? Autumn. So C is our autumn, which means in the southern hemisphere it's going to be the opposite, it's going to be their spring. And then after our winter comes spring, so that's why A is spring. So I answer those in a wee bit of a funny order. 2, here's the answers here. I'm not going to bore you by reading through it. You can pause and fix any that you maybe got wrong. And then for 3, this is for one city, all the different sunrise times, and you had to figure out whether it was southern or northern hemisphere. And I will say loads of really good explanations here. So it's southern because if we look at January, you can look at them all, but if I just look at January, for the sun to rise at 5:30, that must be the southern hemisphere, because for us, January, that's winter time, where our sunrise is really late. So that's what I put down. January has the earliest sunrise time, so it must be summer in January, and that's the opposite of us, so it's the southern hemisphere. Okay, so if you turn to page 140, this is what we are going to be doing today. So you can see here at the top, we're going to be looking at the solar system. Now, obviously I can't give you these 8 cards, however, the same bits of information are actually in your notes. So what I need you to do to answer the questions on these pages, so pages 140 and 141, there's some questions. See if you look over on page 143, these are the cards that is talking about in the notes. So you're going to use a combination of the information that's on these cards and see on 100 and 140, it says use pages 140 and 141 in your textbooks. I'm going to upload a picture of those pages onto our assignment today. So you need to use a combination of those cards that are in your notes and the picture of the textbooks, of the textbook pages, to answer these questions. Okay, so do that for me now. Get pausing, get doing it. Oh, apologies, there's also some questions on 142, so same. I use that same information to answer those for me. Right, so I'm going to be asking you to upload pictures of your answers to those questions for me, and then we'll go over the answers in our next lesson. So for the rest of the lesson today, we're going to get to have a wee bit of fun, okay? So if you look at page 145, I'm going to be asking you to try your best at home to build a wee solar system to scale, and it's just to try and give you an idea of the distances and things that we're talking about, because that's one of the things that's really hard to get our head around. And in fact, next lesson as well, I'll link you some really good YouTube videos so that you can start to get a wee idea of that scale. Okay, for now we'll do this. So on 145, we've got this wee system here to try and figure out some scale that we can use. Okay, so if we look through this, then it's just to try and get the so many millimeters in real life is representing so many kilometers. So if you look here for Mercury, 58 millimeters, which is 5.8 centimeters. On our scale, that's representing 58 million kilometers. Okay, so that's obviously why we have to use a scale. So I'm gonna, well, you can have a go at following this and filling it in, but I'm gonna fill it in here for you, okay? Okay, so I think that table is a wee bit strange, which is why I wanted to fill you in, because normally we don't use all these different units. I've also added in down the side, just because we're more used to working in centimetres, what these distances in millimetres mean in centimetres. So here's what I want you to do. I want you to use like a measuring tape or something to measure out these distances, and just use blue tack, or if you don't have blue tack, just any object like say a pen down or whatever to represent each planet. And what you should see is how relatively close together the wee inner planets are, and then how far apart the outer planets are. So do give that a go for me, okay? And that is it for our lesson today. So just a reminder, you need to use the pictures I'm uploading of the textbook along with those wee cards in your notes to answer those questions. Upload pictures of those questions and then give this wee scale model a go for me, okay? I'll see you next day. Bye.